So let's look at this issue of absolute versus conditional convergence. Okay, so we say something converges absolutely if if we make the terms all positive, it still converges. Okay, we say that something is conditionally convergent is if it doesn't converge when we have all positive terms, but it will converge if it has positive and negative terms. Okay, so conditional convergence means it needs some help. So example would be for the alternating harmonic series. It's conditionally convergent, meaning that if we make all the terms positive, it is a divergent series. The 1 over n series is divergent. However, it is conditionally convergent because if we alternate the harmonic series, we get a converging series. Okay, so this is a case for all p series less than 1. So if we have roots, for example, ones like this down here, these are all conditionally convergent because the terms go to 0 and they alternate. Now it's conditionally convergent because without the help of alternating terms, this will not converge. So if I made this all positive terms with an absolute value, that means that this is a diverging series. But if I make it alternate, we have conditional convergence because it just needs that help to converge. Now absolute convergence, slightly different in that even if it is all positive terms, it will converge regardless. So if it is absolutely convergent, it must be also convergent if it has alternating terms. Okay, so in this case here, regardless of the fact that we're making these terms alternate, this is a basal series, okay, and it will converge to a finite sum. If we let it alternate, well, that's even better. It will even converge more to a finite sum, which is finite as well. Again, we don't care how finite it is. We just need to know if it's infinite or finite. So the absolute convergence theorem states that if the series converges absolutely, then regardless of whether it alternates or not, it must also converge. It's a fairly straightforward theorem. So we can just test this. If we write out the terms of this, we're going to end up with cosine of pi, which is -1 over 1, plus, we're going to end up with cosine of 2 pi, so it's going to be 1 over 4. And we're going to have minus 1 over 9 plus 1 over 16 minus. So this is an alternating, this is essentially an alternating basal series. So what we're going to test for then is, will this converge absolutely? Okay, so what we're going to do then is we're just going to put that and we're going to test it. Okay, and we're going to see, does this converge absolutely? So if I put absolute value around that, and actually I need to make one more little adjustment here because we want to get rid of that flipping of cosine. So we're just going to say that is equal to 1. Okay, it's always going to be either 1 or -1 in the numerator. So we're going to then test this by putting this into absolute value, and we're then going to compare this to, this is going to become a basal series. Okay, so we know that this is convergent. Okay, therefore, this series here, which I'll just write out. We know that this is absolutely convergent. Now, the reality is, does it really matter that it's absolutely convergent or convergent? Not really, because again, we're just interested on convergence. But this is something that we can state then, well, if it converges with absolute values around it, then it's going to converge without the absolute values around it. Okay, so looking at another part here.